Okay, here we go again. So let's look at the next question. So boiling point, melting point. Okay, so what is melting point again? Melting point is the temperature. Okay, the temperature at which solid changes into liquid. Okay, so that when your solid change to liquid, that's your melting. Okay, so the point of that temperature is called your melting point. Okay, very straightforward. So number two, predict the state of matter W at 100. Okay, so W is here. So at negative 120, they turn into gas. Imagine this is gas. In between 120 and 78, they are liquid. Okay, and then above 78, they are gas. Sorry, this should be solid. Mistake here. It's just like water, like guys. You see, water's melting point is 0, right? Anything below 0, they are ice, right? Your fridge is below 0, right? Your freezer, so it's ice lah. So between 0 and 100, okay, like our water here, between 0 and 100, it is a liquid. And then above 100, that's when they become steam. That's your gas. So same thing here. So you see, at 100 degrees, 100 degrees is higher than 78, right? So your state would be gas. Okay, that would be a gas. Give a reason for your answer. Why is it a gas? Because 100 degrees is higher than the boiling point of W. When you're higher than boiling point, so you turn into a gas. Just like your steam. Okay, guys, that's why don't mess with steam. Steam can be as hot. Okay, your when your car overheats, as your dad's car overheat. When your dad's car overheat, when you open that hood in front, and then there's a cap there. You know this thing called a radiator cap. Okay, the radiator cap. On the cap, please learn to read. Okay, there are some stupid people that are stupid enough to go and open this thing. Right, can you see that? Caution, hot. Never open when hot. It's written there. Some people, they don't know. They thought they're very smart. They just open the thing. When the thing sprays out, when your car is hot, when your car overheats, it's even hotter. When this thing sprays out, it sprays out at 140, 150 degrees. Okay, you see, when boiling water, 100 degrees, when it touches your skin, it's painful enough. Imagine 150. This is how you burn off your face. Okay, there. You open your dad's cars, the we call it the bonnet. I think it's called a bonnet. Yes, you open the bonnet, you will see this cap there. Please don't be stupid enough to open this thing. You will know why. Okay, go and do it. Okay, I suggest you go and do it. You will forever remember this thing. Right, so the experimental setup to study physical change. Okay, so this is iodine here. Okay, what is iodine, by the way? Okay, let me show you iodine. Iodine is this really cool looking crystal. Okay, iodine is this really cool looking crystal. They are solid, as you can see here. They are this black color solid. Right, when you heat them, when you heat iodine, they don't melt, but they will straight away change to this purple color gas. Ooh, looks cool, isn't it? Okay, so there's no liquid here. This thing is just like your dry ice. Okay, when you heat it, they change it to gas straight away. But your teacher won't let you do this because this thing is actually quite poisonous. I mean, just by looking at the color, this thing is not nice to smell in, okay, to inhale in. So what is the color of vapor P? See, when I heat iodine, iodine will change to gas, right? So this is your gas, it will be purple, as I showed you on Google just now. And then when they touch this ice up here, they will turn into solid again. See, so this is your solid L. Your iodine crystal comes here and it turns into this solid again. So solid L is black because your iodine is black. So where is the solid L deposited? Okay, they are deposited below the watch glass. okay, below the watch glass. Right? So what is the changes that occurs in the beaker? What is happening here? We can say iodine crystals turn into gas, then solid. Okay, change it to gas, then change it to solid again. So what is this process called? As I said just now, this process is called sublimation. Just like dry ice. Okay, just like your dry ice. Okay, your dry ice will, turn into gas also. So explain the heat change in the above process. What is the heat change? So this one, when they change to gas, they gain heat. When they change to solid again, they lose heat. So you can say for P, they gain heat. For L, they lose heat. Okay, they gain heat, they become hot, they sublimate. Okay, I hope you guys understand what I'm saying here. Right, so easy question. So we skip number 9 lah. You know why? Because it's the same question as the up there just now, the balloon question. So we skip this. Right, so you guys have any question? You guys have any question? While I drink my water. Okay, quiet means you have no question. So Jaden, are you nervous for tomorrow? Are you nervous for tomorrow? Did you study all this while? If you do, there's no need to panic lah. I mean, if you don't, okay. Okay, that's nervous is a good thing. Nervous is a good thing. Panic is not a good thing. Okay, you shouldn't be panic. Panic means you didn't prepare. If you didn't study all this while, then you should be panic. Now you're just nervous. Okay. Hey, think of the good way. Look at the bright side. If you finish your exam, then you're free. We are going to learn year 9 stuff. Okay. Oh, by the way, guys, in December, we are going to year 9. Okay. Okay. I know, like Darwin here, you haven't finished your year 8 yet, but don't worry, it will overlap. Okay, it will overlap. So December, we are going straight to year 9, which is a good thing. Okay, we are learning new stuff in December, guys. Okay, none of this boring shit again. Okay, so anyway, let's go to number 10. So this is your air pressure. If you still remember your air pressure. So basically this is your, a container. So you see all these gas atoms, this gas particle, they're just running around. So how do you produce air pressure? Right, let me explain this again. How do you get air pressure? This is your balloon. Imagine this is the wall of your balloon. Inside your balloon, you have air particles, right? When they bang on the wall, when this atom, they bang on this wall, you have millions of atoms, right? So this millions of atoms, they bang, 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 bang on this wall. This banging creates air pressure. All right. Imagine like 3 of us, we are trapped in a very small room. So we run around the room. So we will bang onto the wall, right? Okay, I bang to the wall, then I run again. I bang to the wall, I run again. So 3 of us, we bang on that wall. The banging will produce air pressure. So more banging, higher air pressure. You see, very easy to remember this. All right. So how is air pressure produced? Okay, there's a typo here. How is air pressure produced? Okay, they are produced by collision. Collision means you bang. Okay, collision uh, of air particles with wall of container. Okay, let's say you are a gas particle. You run and bang on a wall. That banging will create air pressure. So B, then the container is placed in a hot place for 15 minutes. Explain what happens to the air pressure. So imagine when you put it at a hot place. When it's hot, what happens to these atoms? They run faster, right? They run faster, right? If I put you in a room and I heat up the room, you're going to run faster because wow, so hot. So you run. So when there's more running, there's more banging. More banging, higher air pressure. Right? So this is why when you heat a balloon will burst because it's too much pressure. Okay, so the pressure will increase, okay, because there's more collision. Okay, more collision, more banging. So next, if the volume is reduced, if I make this room smaller, what's gonna happen? Same thing. You're gonna bang on the wall more. Imagine 3 of us in a big room, less pressure because we can run around wherever we want. But when I make the room much smaller, we are going to bang into each other. So it creates more air pressure. So same thing, the answer. The pressure will also increase. Same thing, because there's more collision. Okay, there's more collision. So to increase your air pressure, there are 2 things you can do. You can increase your temperature, make something hotter, or you can decrease the volume, make something smaller. So put it this way, how do you burst your balloon? How do you break your balloon? Very easy, you can heat it, or you can make the volume smaller. How do you make the volume smaller? You press it. You press a balloon, they burst, right? Okay, they burst, right? Okay, because when you press it, you reduce the volume, you increase their pressure, so they burst. Okay, easy, really that easy. Okay, so next 11. This atmospheric pressure, I'm just gonna skip for now because it's not, not very important. But just to let you know, the higher you go, okay, imagine this is the atmosphere. This is the atmosphere. When you are at a very low ground, there's a lot of air pressing on you. So this is high pressure here. When you're at a very high place, let's say you go to Kinabalu, Mountain Kinabalu, there's very little air on top of you. So there's lower pressure on you. All right. So this is why when you go to very high mountains, your surrounding has very low pressure. It is very hard for you to breathe. Okay, so like I said, you want to climb to, let's say, Himalaya, you can't because you can't breathe up there because it's so damn high. Okay, there's so little pressure, you cannot breathe normally, you will feel nausea. This is what we call altitude sickness. Okay, altitude sickness, and you feel very unwell, you feel very sick, you feel like vomiting. That's what happens when you go to high mountain. Okay, so guys, to challenge high mountain, to climb a high mountain like Himalaya, it's no small feat. It's no easy task. You don't just say, oh, you know what, I'm just gonna challenge Mount Everest tomorrow. If you're a couch potato, if you're a very unfit person, trust me, you will die up there. Okay, so please don't please don't joke. All right, so A compare atmospheric R and S. So you can say atmospheric of R is higher than S. You know what? I'm just gonna write it this way. In exam, you can write your full sentence all you want. I am just lazy. All right, and to make your job easier. So B, based on the principle of air pressure, explain the condition faced by Justine at location S compared to his friend at R. So how is Justine like? So he has lower pressure. Okay, so we can say Justine has lower air pressure or atmospheric pressure than R, than his friend. So by right, his friend should breathe normally. High pressure is good for you, you see. You can breathe normally, but when you're up there, it's very hard to breathe. High mountain is very hard to breathe. Next time you go climb mountain, you understand. You might say, sir, I go to Genting, right? Genting is high mountain, right? Yes, it is. But why don't I feel shortness of breath? Why don't I feel altitude sickness? Because Genting is not very high. Genting is not very high. Okay, Genting is like a small hill. Not a small hill, it is a mountain, but it's not a very big mountain. Okay, I'm talking about like Kinabalu, like really high mountains. Genting is okay. Okay, I mean, you don't see people shortness of breath in Genting, right? No. right? Things like that. So guys, you know what? I'm just gonna skip this. Okay, you understand? Then that will do. So guys, go home and Jaden, if you want, finish this yourself. Okay, finish this yourself. Next week I will still continue with this. I will finish this first for our November. Okay, because like Darwin here, you are not. I don't think you have learned this, right? This atom thing. Okay, I'll go into this next week. Okay, so next week I'll finish this first. Before December, we will move on to year 9. I'll let you learn some year 9 stuff on December because okay, let's learn something interesting in December. Okay, so guys, if you have no question, I will see you next week. Okay, I'm gonna stop here. So we should have a happy Tuesday. I will see you again. So good luck to you, Jaden. All the best to you. I will see you next week. Okay, so take care. See you. Good night. Bye-bye. Bye, guys.